Well, hello and welcome to the next episode of 3D30. Today we're going to talk about coding 3D printed parts. Definitely an interesting topic. I learned a lot about this. In case you're new to 3D30, 3D30 is Velo3D's YouTube and LinkedIn live channel. So both channels are active now. We host this show about every 2 weeks with a different topic. We look at downstream, we look at upstream, we look everywhere in the 3D printing industry for metals specifically. So if you're interested in learning about this technology, this is a great place to start. We do put these all of these sessions are on YouTube, and so you can find all of our library there. So if you're looking at the additive manufacturing industry, you've probably seen parts, and you've seen these amazing, elaborate, complex geometries. And a number of times we show them as printed because we want you to understand what you're getting right out of the printer. And sometimes they're machined, and that tends to be about as far as we go. But for a number of industries, especially like DoD or Navy, Marine, aviation, showing a as printed or a machine part isn't quite enough. You're going to need to coat this. So coating technologies can do a number of things for us: corrosion resistance, adhesion, surface protection, aesthetic properties. But with these parts, you get these complex internal channels, and it's not always easy to coat. In fact, for some parts, this was seen as impossible until now. So we are live today, so please feel free to drop in a question. We would love to hear from you. We want to get comments from our audience. Let us know what you're thinking, and you can talk to our speakers directly. With no further ado, let me introduce our speakers. So today I'm happy to bring on to 3D30 Ted Ventresca. Let me bring you on here. Okay. And Shay Davis, both from CHEMEON Surface Technology. And we also have, you might see a familiar face if you've watched 3D30 before. This is Kurt Wagner from Wagner Machine Company, CEO of Wagner Machine Company. So how's everyone doing today?
Great.
Doing great.
Thanks for having us.
Yeah, happy Wednesday. Ted, let's start with you since you picked up a cup of coffee. We'll get you speaking first. Can you tell us a little bit about yourself?
Hi, Mike, and thank you very much for having us here. I've just leading into this, I've had such an interest in 3D printing, going back years, and I'll share that a little bit later on. But I've been with CHEMEON Surface Technology as their president and COO for 8 years now. And prior to that, I was managing director of an international consulting firm, worked in sales management with some large corporations and media companies, actually, globally. And it's such an interesting creative field, the metal finishing industry, and there are amazing advances, and two of which you're talking about today. So it's great to be here.
Awesome. And Shay, love your background. We found some common ground in there. Could you kind of give the audience a little bit of the appreciation of what your background is?
So I have a little bit of automotive mechanic work. Then I joined the Army, and I was a crew chief on Black Hawk helicopters, sometimes called a glorified inspector because we spent a lot of time to inspections and whatnot. But after the Army, I got out and I decided to get a degree in chemistry and spent about a year in the natural gas industry, helping commission a plant and operate it. And then from there, I decided to move back west, where I'm from, and in the area roughly. And I found this job by chance, worked in the lab for about a year and a half as a chemist, and now I'm in business development and tech sales.
Yeah, it's our common Army background. And I couldn't remember if it was Blackhawks or another model, but it was the Blackhawks you mentioned. And I've got a sweet spot in my heart for Blackhawks. I just remember them being on the ground in the morning, right before dawn, loading up and looking up and just seeing the static electricity forming on the blades. I just thought, I love that. I'll always have that in my mind when I think of Blackhawks.
Somebody was in the sandbox then, I take it.
Yeah, a little time in the mud.
Yeah.
All right, Kurt, we know you well, but in case somebody is new and the first time hearing from you.
Nope. I don't know if I locked up or you guys.
Uh-oh.
You did.
I was hearing you okay for a little bit.
All right. I think I'm back. So I'm CEO of Wagner Machine. We've been doing precision machining for about 40 years. And about a year ago, we decided to add metal additive, and we've been doing that for about a year now with a sapphire machine from Velo3D. We print in F357 aluminum.
Awesome. And you're known for
making impossible parts.
There we go.
So, yep, that's we've been doing that before additive, and now we're pushing the limits even farther.
Yeah, it's Mr. Impossible himself on our show today. So Ted, we kind of talked a little bit about what CHEMEON does. Maybe you can give us a broader perspective.
Sure. What we are is a chemical manufacturer and specialty chemical company that creates chemistry specifically for the industries such as metal finishing, anodizing, powder coating, in various ways, whether it's medical products or automotive, aerospace, electronics, aviation. You had mentioned at the beginning, Mike, and this is our work with Kurt as well, as the corrosion protection, the corrosion resistance, because CHEMEON has some very unique patents and unique chemistries that are military specified. They meet certain mill DTLs. And between that and between the additional training and the support that experts like Shay, and we have a whole range of R&D, PhD scientists, and chemistry team developing new technologies. So between that, the support that's provided to customers and the relationship that we forge, that's it's one of those key things that's beyond the chemistry.
Nice. And Shay, as the chemistry expert, what are you working on?
So I'm actually trying to, storm the industry, aerospace, defense, ground, with this new product to replace hexavalent chromium, which has kind of been on the out and out in the U.S. Finally, it's already been kind of pushed out in Europe for REACH compliance and RoHS, RoHS. And so we're kind of basically, up until recently, it's been a challenge to penetrate into the aerospace industry for the lighter aluminum alloys to, push out hexavalent chromium with a good replacement. And so eTCP is this new next generation product, standing for enhanced trivalent chromium pretreatment, that can really be a drop-in replacement, offering exceptional corrosion resistance, some paint adhesion needed. It can be used as a masking agent, an anodic seal. You can put it over different plating processes like zinc nickel, CAD, and electroless nickel to extend as a top coat to extend their salt spray testing, corrosion testing. So it's kind of exciting to not only offer anodizing chemistry, which is a thicker coating, but this is a much thinner, conductive protection for light metals.
And you mentioned this technology might have a common history that people are familiar with, something from Hollywood potentially.
So yeah, a lot of times when people ask me, "What do you do?" Well, have you ever seen the movie Erin Brockovich? She fights that carcinogenic gold hexavalent chromium that causes cancer. So we, as a company, we really pride ourselves on focusing on the more environmental, REACH, RoHS compliant stuff. And one of the industry needs has always been to have something to replace that, as well as potentially to be able to see it. So this eTCP also offers a visible identifier with a bit of a color to the product. Because hexavalent chromium, the native species, gave a goldish, brownish, yellow hue, which basically the current trivalents were clear and also not quite as robust.
So you mentioned kind of a coating, and from an application point of view, what is a designer trying to do when they coat a part? What are they trying to accomplish?
It depends. So in most cases, it's often corrosion resistance performance. So they need to go by this test matrix that goes by or metrics that 168-hour salt spray, 336-hour salt spray, depending on what the application is. That's most common for aluminum. You might have 120-hour for, say, cadmium, or it might be 240, I believe, actually. But regardless, it's you want to hit that corrosion resistant performance. In some places, they only need paint adhesion, like under powder coating and stuff like that. And this kind of gives a dual protection. And then being able to know that your parts were coated is kind of nice. So you actually know that they've been processed, they're protected, and you can kind of speed up production in that sense. But it's can be used in a lot of ways, like getting into areas where you can't get that electrolytic or the coatings in there, or if you're trying to anodize something and it doesn't, you need to be able to get into small, shafts down tubes and whatnot. This can still provide that protection, a level of protection, whereas if it was bare, you'd get nothing, since you can't get the anodized, sometimes in there for those kind of plating processes.
And you mentioned having a color to verify it. You mentioned kind of getting in these internal spaces. It sounds like having a conformal coating is important, but what's the downside if it's not conformal, if you have gaps?
So then you can have excessive corrosion potential, especially if it's in those weird channels and areas where things can, like moisture can pool or collect. At least you have this kind of barrier for this conversion coating that reacts with the aluminum surface, and it helps protect it against that, those interesting areas where you can't easily inspect and you can't easily clean out. So it just adds an extra level of protection and extends the life of your parts.
Kurt, we kind of hinted at it earlier on. You're using this for 3D printed parts. So what is it about this that creates a synergy between CHEMEON's technology and 3D printed parts?
The biggest thing is what Shay was just talking about, where with 3D printed parts, we're running into parts that require coating in areas that normal processes can't get to. So powder coat, obviously you have to have access to the part to be able to spray the powder on. Same with a wet paint process. But something that a lot of people might not know is coatings like anodize and a lot of different electroless coatings or electroplating processes have to have access. They won't coat internal features. So as we've run into parts that have internal features that require some sort of corrosion resistance, it's been really tricky to find suitable coatings. And we've run into applications where we use specialty ceramics to coat internal features, but that's a really expensive process. This is a much more affordable process, and it's something that we can do in-house, so it really doesn't have a huge impact on the part cost, and it meets the requirements in a lot of situations.
Now, this is one of these parts that we've been talking about. Can you give us a little bit of history on this one, and then I'll show the internals that we had up before?
Yeah, so this is a turbine housing. It's for a very high performance application where they're trying to squeeze every last bit of efficiency out of it. And originally this was designed as a machine component, and in an attempt to get a little more efficiency out of it, they added cooling channels that you could see before on the section view there. So there's a large cooling channel that goes around the entire outside of this part. And what they end up doing is they pump fuel through that channel, and it cools the housing and preheats the fuel and gives them a several percent efficiency bump. So that's the application in this case. I've had other applications with various corrosive environments where internal features were a concern.
And so when you're coating this, you're coating the internal or channels as well. This little
so this one,
here.
Once we printed the part and then had it heat treated, and after finish machining, which we also do in house, then we do the eTCP coating on this one. So, and that'll coat every surface of the part, not just the visible and external surfaces.
And you mentioned in-house. Is this coating something that you have to send out for, or are you able to do this in-house as well?
We do this coating in-house, which is a big advantage. We've been using CHEMEON's TCP HF for a long time, probably 10 years or so. And when we started running into these internal coating issues, we called them and asked, hey, could we use the TCP coating that we're currently using? And because of the material we're printing in F357, they said that TCP-HF wouldn't work well on this material. There's some limitations, but they said they had just come out with a new process that works on a wider variety of aluminums and should work on this. So we actually tested this on a different project than this, coated the parts, did salt spray tests and everything else, and verified that it worked well for the F357 aluminum.
And are you able to do the
and we can do this process in house. So we've got a chem film line in house that we're using. It's pretty straightforward to set up and maintain. So.
And so you're doing the coding and the testing in house, or just the coding?
CHEMEON does the testing for us.
Okay. Nice. So, and Shay, I'll kind of come back to you. Could you provide a little bit, some depth in what kind of testing are you doing? What are you checking for?
So some of the things you have to, so, as I mentioned, he does this in house. We have, either 3 chemistry or 2 chemistry kind of tank setups. It's probably one of the easiest processes you can do in house next to maybe passivating. It's super simple and flexible, and I teach a lot of people how to do it who have no engineering or chemical background. But for us, what we recommend, monitoring concentration and pH, and then to check, basically validate your process. It's recommended to do salt spray performance testing. So per mil DTL 5541 and 81706, which is the governing spec for the 5541, most shops and facilities and suppliers would have to do 168 hours. So use salt spray, salt fog chambers to do this in accordance with ASTMs. And then we also do coating weight tests to make sure you're getting a good coating. Sometimes if there's ever issues, but there's several things you can do. Coating weights, electrical resistivity if you need conductivity, instead of we want to make sure it's not impeding. One of the things with hex chrome is it's a thicker coating, so it would often you'd have to have a different process to make sure that when you needed an electrically conductive surface that you didn't coat too thick. Well, this same process meets both. So, but they still do the electrical conductivity testing, the salt spray testing, coating weights if needed, and then paint adhesion as well when there are surfaces that are accessible that do get painted. And then we have an external NADCAP and certified lab that will mirror a lot of our testing, make sure that we're operating at a level that it's not just held internally, but we use external testing as well for validation.
And we mentioned this visual verification. We actually have an image here. It has a certain color to it. How would you describe? I would think purple, but I think you had some more colorful language.
Lilac. Lilacs, or like the purple flock that you might see on the side of a mountain, out here on the west at least. So that color is actually dependent on the alloy series and your pretreatment. So sometimes it's a little stronger, sometimes it's a little bit more like a brownish, purplish, bluish. Could have a blue hue. You can reduce your immersion time for certain alloy series where you don't really want to see as much color. But with it shows up very well on the lighter alloys, like 2024, those that have a lot of copper in them, or zinc, and so it has a variation. But violet would be from the rainbow if you're gonna go that way.
No, I think we're going to need some purple parts at our trade show from now on. They look pretty good. That'll give us a different part to talk about. And just as a reminder, we are live today. If you have any questions about 3D printing, coding 3D printed parts, the technologies all around this, please feel free to drop us a question. We'll get to it live. Actually see something coming in now. Okay, so there is a question here. Oh, hey, Roger. Good to hear from you. How thick is the coating in microns, and what is the temperature limit that it could, I assume, withstand in use? And this is coming from somebody who is making microturbines.
Okay, so the coating is roughly around 120 nanometers thick, give or take 10 or so nanometers. Very, very thin coating, much thinner than, say, 1 mil of anodic coatings. And then the temperature limits, they're basically stated in the mil spec. Hexavalent chromium tolerates less high temperatures, but the mil spec says you can go up to 250. If you're powder coating, it is fine under powder coating, which is an exposure up to 500 degrees. And it still withstands that for those kind of applications. But for general applications, what we do is, you follow the mill DTL 81706 and try to keep it around that level. But you can also test, like we always say, test everything. So if you have certain parts that need to go through exposure of 200 plus degrees Fahrenheit, then we do testing. You basically test it, then you salt spray test that, on panels of the same alloy series and whatnot. So you can push the limits a little bit, but we tend to fall back to the mill spec because that's where you have to be able to reference something, right?
And when you say 500, is that in Fahrenheit, Celsius?
Fahrenheit, sorry, yeah. So it's in powder coating. They go up to about 450 to upwards closer to 500 degree Fahrenheit for curing it.
Okay, awesome. So Roger, hopefully that answered your question. So I do want to kind of switch over to Ted. If you could summarize for us a little bit here, what are the major differentiators for this technology? What should people really take away from this?
Shay and Kurt have touched on truly some of the unique things, but the major differentiators is the performance of eTCP, because trivalent chrome has been around for decades. The trivalent chrome that has been specified for military use and meets this MIL DTL has been around since probably the early 2000s. CHEMEON and our team here were actually the first individuals to commercialize and scale trivalent chrome, the military specified trivalent chrome, which was originally created by the United States Navy for commercialization. And we've been able to scale that. But the unique thing about trivalent chrome, and we've been touching upon this, whether it's F357 for additive manufacturing or 2024 aluminum, is the performance. There are nuances to get it to work consistently well and meet conformance on 2024. The unique thing about eTCP is it consistently performs and conforms on 2024 aluminum. And in addition to that performance and performance on 7000 series and consistent performance on other alloys as well, the additional aspect is when this is being used either by the DoD or by tier 1 providers or captive shops, there has been a history of use for decades, 8 decades plus, of utilizing hexavalent chrome, in which that colorization is key, because that person who is the applicator, they may be going through that part and they are not from necessarily the chemical or science side. They're the applicator whose job is to provide the application to that part, and they need to have that color verification. So in addition, knowing that part is coded and protected is an additional value to it. But it's the 2024 performance. It is and also too, I think we go back to it, and I think Kurt is a perfect example of this collaboration of trying to find that solution and being there to support their process. And when metal additives and additive manufacturing of 3D parts in metal is now just going from a prototype part to hundreds of thousands of parts, that consistent performance and conformance has to be in place. And Kurt certainly has perfected that, and your 3D printers have certainly perfected that. And the great thing is that CHEMEON eTCP is a coating that complements that and supports that from a corrosion standpoint.
We have a question coming in from Sanjay. What coating should be used on parts for withstanding high pressure? So he mentions at least 4 bar. What advice would you give?
Tag.
Yeah, that one. That's what we need Sean, our PhD senior VP of Tech, on that one. I think maybe noted. Get back to you on that one, Sanjay. It's the thing is, once this coating is actually dry, it's very hard coating. It's very difficult to remove and withstand quite a bit. It's not like an oxide layer from anodizing, I use that as a lot of reference, but when you build that oxide layer, it's 2/3 above and 1/3 below the original substrate surface. But this chem film, it bonds with the substrate and forms a very hard coating, in the sense that it's difficult to remove. So once it's dry, it takes a strong acid to remove it. So that potentially could be an application that it could be used in with high pressure, but I would need to know a little more detail and then probably get back to you on something like that.
And as a kind of a segue, usually we put this in at the end, but what would be the best way to get in touch with either you or the PhDs you mentioned? Like if people do have questions and they want to dive deeper into their applications, how should they do that?
So I mean, on our website, just CHEMEON.com, we do have an email. It's info email. I actually get that email, so I see every sort of information that comes in. But you can also reach me at just my first initial last name at CHEMEON.com, no dots or anything. And I'm pretty accessible. I mean, I may be the salesperson for all our global customers all over, but we're a small company that really kind of has a very good ability to reach us, to ask us lots of questions, and a good team I can reach out to you in our tech center.
Perfect.
Yeah.
So, yeah, go ahead.
I'll just add to that, Mike, that the great thing is when people do interact, and Kurt is certainly a great example of this, you can actually get to the individuals who created the chemistry or have commercialized the chemistry and brought it to market. So, I mean, it's a very short step process to get the answers or the support that you need. And, right now we actually have an OEM, automotive OEM, and a number of tier one process shops in our training for anodizing and trivalent chrome right now in our training center downstairs. So it's much more than just selling or providing a chemistry. It really is the entire package.
Yeah, it's nice. And, we've heard from some people already. I know some of these industries are represented here, but could you give us a perspective on what types of industries would be common for you to provide solutions for?
Well, you certainly have the DoD. We have a wonderful relationship, a collaborative relationship with the Army, and a nod to both of you, to the Navy, Air Force. We're in projects with the Marines on a very interesting field application of eTCP. And that certainly extends to Coast Guard and National Guard as well. But of the automotive industry, aviation, solar, if I'm missing anything, space, of course.
You've got a couple customers for space and aerospace in general.
And satellite aerospace.
Yeah, don't forget about work with Boeing.
Absolutely. And the work that Shea does with the OEMs is making them aware of this alternative. Because again, too, hexavalent chrome has been used in anodizing as an anodic seal. It's been used as a coating on the alloy itself, on the skin of aircraft. And when you think of getting into the intricate parts that Kurt assembles and designs, and when you're bringing multiple parts together, getting into the coatings of those intricate internal aspects is something that is unique, and especially that it performs, and you can be the end users have a clear, proven comfort level and validated comfort level that part is coated. All of that combines to, being we try to be a great resource, not only in just the chemistry we provide, but everything we provide beyond that.
Yeah, and Kurt, well, actually, I kind of want to hear from you since we're sort of on this topic of working with CHEMEON. How is it working with CHEMEON? How did you first learn about the company, and what's the relationship been like?
I actually don't know how we first started working with CHEMEON. I'm not sure how we got in touch with them, but the reason we got in touch with them and decided to bring this process in-house was because we had electronic components that needed chem film coating on them, and they also had to get paint process done to them. And our painter had been taking care of the chem film process, and their vendor had some sort of issues. They were having some quality issues. And as we looked into that, we realized that there was a lot of extra shipping going on, and the quality issues. We decided to bring that in-house, and it saved us, it saves us a lot of money on different parts. But that was kind of why we got into it, was one specific project. But over the last 10 years or so, it's turned into a process that we actually, inform a lot of our customers about. It's something that actually provides a benefit for people who didn't didn't even know it was an option. It's something affordable and just gives them a little bit of something extra. So that's worked great. But as far as working with CHEMEON goes, yeah, it's been great. One of the things I like to say is, we're excited about machining and doing things that people think are impossible or challenging, just trying to solve problems. And one of the reasons that we chose to work with Velo is because you guys are excited about the same thing, right? Doing stuff that hasn't been done in additive yet. And CHEMEON is kind of the same way. You can get a hold of Shay. She'll call on her cell phone on the way home from work just to talk about this stuff. So they're excited about what they do too. It's extremely nerdy. I don't understand most of it, but they're very excited about it. And it's great to work with somebody who's excited about what they're doing, right? So when we have a question or a new application, we can call them up and they walk us through it and give us suggestions. And so far they've been spot on.
And I mean, you mentioned kind of your customers. Have you had any feedback from the customers? What's their experience in the end use of the code?
Most of the time we don't get any feedback from them, which we assume is good, right? You don't hear any. That's one of the sad things about it, right? Codings, if they work, you don't usually hear much about them. So that
kind of like marketing,
right?
Marketing's working. Nobody tells you anything.
Yeah. So we don't get a lot of feedback on that, but we have had, just in general, people who've appreciated being able to provide a little bit of something extra, right? That they, sometimes providing something that they needed and they didn't even know they needed, right? So that's been nice. That's been really nice for us.
So we are at 30 minutes. I'll give maybe enough time for one more question if somebody wants to jump in real quick. But before we do that, let's go around the horn and just summarize your thoughts. Shay, why don't you kick us off?
So obviously Kurt is Wagner Machine's been a great customer of ours, and we have everywhere from that tier 3 supplier all the way up to the OEMs that we work with. And it's been an amazing experience helping these suppliers be able to provide their customers, their end users, the defense projects and jobs, or aerospace jobs, or whatever their end users are. We can work with all of them. And it's been really, honestly, I love the experience doing this. And Lockheed might reach out and they'll come here and do some work with us, or we'll do some work with them. Or if we're IVD projects for to try to discover what we can do to replace hexachrome with for stuff for Airbus, or conversion coding for Boeing, and these or space customers, or all these challenges that people need for these hexagon replacements. And so it just being able to see that our product, this eTCP, this new awesome product, can be used in like this new innovation with 3D metal printing. Up until recently, I've just known about the plastic stuff. So this metal stuff is so awesome, and it's really exciting to see that there's always something new that we can work on. It never really gets monotonous or stagnant. And whether you're small or big, it doesn't matter with us because we love it all.
Yeah, we say we work on everything from missions to Mars to racing cars, so a little bit of everything in there.
We even have this race car engine people using our eTCP now. It's pretty cool with North Carolina.
Very nice. Ted, closing thoughts for me?
Yeah, I'll echo a good part of what Shay has said, and I'll share with you that going back before even joining CHEMEON, I was in Washington D.C. and involved with the military in that respect from a business standpoint. And I was at the unmanned vehicles shows, but this is going back 11 years. And there was an excitement in the military about talking about putting 3D printers actually in the field and on ships as they needed parts, one-off parts. So when you think about what has happened in 11 years and 12 years, that rather than just a one-off prototype part, that was not a mission critical part, that was just something that they needed to fix, and it was a plastic part that they worked on then, to what Velo has been able to create and what Kurt has been able to perfect in creating and replicating hundreds of parts and parts that are critical in tolerance, in design, and assembling these parts. and now being able to provide the coating aspect that provides that additional corrosion protection for this mission critical. When you think about the way all of our industry has moved in just a decade, that's what really is. And thank you for Kurt for saying that, and including us with you and Velos. That's what we're really excited about, and that's what really gives us some great possibilities.
Nice, Kurt. I'll let you close this out.
All right. Well, I guess I'm gonna tack on to that. I think what I would say is the most interesting part of our job is solving challenges for customers, and the vast majority of the time, that's not just a machining challenge or part design challenge or something like that. The vast majority of the time, solving the tough problems involves connecting people, right? So it's great to be able to work with different vendors like CHEMEON or Velo, different machine tool manufacturers, everybody that we work with, and connect the dots so that our customers can end up with the ideal part, not just something that's good enough, but the ideal part for whatever their application is.
Awesome. All right, Kurt, Shay, Ted, thank you. Great panel today. And thank you, audience, for joining us. That is going to be a wrap, and stay tuned. I think our next session is in 1 week. Make sure you follow us on LinkedIn to get the latest information. I'm not going to tell you the show. You can find out on LinkedIn more about it.
Thank you.
Thanks.